Hello everyone. Today we'll be looking into a chemical engineering question from GATE 2021, question number 50. Reactant A decomposes to products B and C in the presence of an enzyme in a well-stirred batch reactor. The kinetic rate expression is given by minus Ra is equal to 0.01 Ca by 0.05 plus Ca in mole per liter per minute. If the initial concentration of A is 0.02 mole per liter, the time taken to achieve 50% conversion of A is dash minutes rounded off to 2 decimal places. So this is a question from ideal reactors in chemical reaction engineering, and the reference NPTEL video can be found in module 1 lecture 10 design of batch reactors chemical reaction engineering 1 homogeneous reactors by Professor K. Krishnaya, Department of Chemical Engineering, IIT Madras. So here the given reaction is A decomposing to products B and C in a batch reactor. So A gives B plus C in a batch reactor, and the reaction rate minus Ra is equal to 0.01 Ca by 0.05 plus Ca. The initial concentration of A, Ca0 is given as 0.02 mole per liter. And the required conversion that we want to achieve, Xa is equal to 0.5 or 50%. And we need to find the time required for batch reactor to achieve this conversion of 50%. So by using the energy balances or material balances, we can derive the equation for batch reactor as T batch is equal to Ca0 into integral of 0 to Xa dxa by minus Ra. So here T batch is the time taken by the batch reactor for batch operation, Ca0 is the initial concentration, and Xa is the conversion required, and minus Ra is the reaction rate. So T batch essentially means the time taken by a batch reactor to achieve a conversion of Xa. And we can obtain this equation by the material balances. So just substitute the values that we have. So T batch will be 0.02 into integral of 0 to Xa, which is 0.5 dxa by minus Ra, and minus Ra will be 0.01 Ca by 0.05 plus Ca. So T batch is equal to 0.02 integral of 0 to 0.5 0.05 plus Ca by 0.01 Ca into dxa. So this question is a straightforward question, and we just have to solve this integral for this question. So the first step is we can separate this integral into two terms. So the first term will be integral of 0 to 0.5, 0.05 by 0.01 Ca into dxa, and the second term will be Ca by 0.01 Ca, where Ca and Ca will get cancelled. So it is important to note here that Ca is a function of Xa, or the final concentration is a function of the conversion required. So this Ca will be equal to Ca0 into 1 minus Xa. So Ca is a function of Xa, and we can write Ca in terms of Xa like this. So T batch is equal to 0.02 into integral of 0 to 0.5, 0.05 by 0.01 into 0.02 dxa by 1 minus Xa plus integral of 0 to 0.5 1 by 0.01 dxa. So now all we have to do is integrate these equations to the limits given from 0 to 0.5 and find the values of this integral and this mathematical expression to find the value of t batch. So we can proceed by these following steps. The integral of 1 by 1 minus xa will be minus ln of 1 minus xa, and the second term integral will be xa, and both will have the limits from 0 to 0.5. So just apply these limits here. Ln 1 will be 0. So it will only be minus ln 0.5 plus 50. So do the mathematical operations for this and we'll get the final answer as t batch is equal to 4.46 minutes. Thank you.